Welcome back, engineers. We are discussing common techniques and algorithms in system design, and in this video we're going to look at consistent hashing. I hope you're ready. Let's get started. So let me close this. So before we get into what is consistent hashing, let's try to understand what is the problem that we're trying to solve here, right? So let's say we have a simple client-server architecture like this. Let's say we have a client, we have a server, and let's say we have some kind of a database, right? So as the application grows, one database would not be enough, so we'll try to scale it up in some way. And let's say we are going the route of horizontal scaling, so we are trying to add more and more servers. So just adding the servers won't be enough. We need to distribute the data among these servers that are available to us, right? So what we'll do is we'll put some data here, we'll put some data here, we'll put some data here, so that there is some even distribution and all our servers are working efficiently, right? So this is horizontal scaling. So how do we know which data point is in which server? So we use something called as simple hashing to check that. So how does this work? Let's say we have some key, some data point in our database, and we want to know which server has this data point, right? So we send it through a hash function. So this hash function can be anything like an MD5 hash function, and it takes in a key. So what is this key? It can be any unique identifier for our data point. It can be a session ID, user ID, or any file name, and we pass it through this hash key and it gives out some number. So it is a deterministic function, which means that every time you pass the same input, it will give out the same output, right? So using this integer, we will do a modulus of number of servers, right? In this case, let's say we have 3 servers and we are doing a modulus of 3, and we get some number which will give us the identifier for one of these servers. Let's say the output of this hash modulo 3 is, let's say, 2. So we know that our data point is in this server, right? So that's how simple hashing works. So this works really well when the data is uniformly distributed and the number of servers is not actually changing, right? But most often than not, we'll have to keep this dynamic because we don't know when a server might go down or when we will need to add a new server, right? So let's say we are adding a new server. Let's say we are adding S4. Now the modulus has changed because this 3 is nothing but number of servers, right? So instead of 3, now we are going to have to do it for modulo 4 for all the data points in all the servers, because they are now shifted. We now have to move all the data points to different servers, and that is a huge operation, right? So almost all objects must be redistributed, and this is a very expensive operation, and depending on the size of your database, the downtime also may be impacted, right? Same goes for when a server goes down. Let's say a server went down like this, S3 is down, let's say, or S2 is down. Now again the modulus has changed. Now the modulus has been reduced to 2, right? So again all the data points must be redistributed among the remaining 2 servers so that our database is back to a consistent state. Again, almost all objects must be redistributed, and this is a very expensive operation, and that is the problem which is being solved by consistent hashing. So let's see how consistent hashing looks like. So in the previous step where we discussed simple hashing, we were hashing the keys and then we were just getting some number and we were just going to that respective server. So in consistent hashing, we hash both servers and objects onto something called as a hash space, right? So let's see how that goes like. So we have objects which are nothing but our database objects, and then we have servers. We pass it through some kind of hash function just like before, and we give it some identifiers. Maybe it's an object identifier or a server identifier, and we get some kind of an integer output, right? Some deterministic output. Now what we'll do with this output is we put it on something called as a hash space, right? So this hash space is a logical concept. This is a logical concept. We don't actually have to physically implement it. It is a theoretical understanding of a hash space, right? So what is this hash space? It is nothing but a sorted array of size of varying length depending on the hash function. So if it's a 32-bit hash function, we have 2 to the power 32 as the size of this. So if it's a 128-bit hash function, we get 2 to the power of 128 size. If it's a 256-bit hash function, we get 2 to the power of 256. So again, this is a theoretical concept, and what we'll do is we will just connect the ends of this hash space to form something called as a hash ring, right? So again, this is a huge array, but we're not going to actually physically implement it. It is a theoretical concept to understand how consistent hashing works, right? So this, when we connect the ends from here to here, let's say, we get something called as a hash ring. So why do we need it as a ring? That is something we will see later in this video, where we will discuss how objects are mapped onto this hash space, right? So for now, let's just understand that there is a huge array and we can put some stuff in it, right? Now let's see what is the stuff that we can actually put into this hash ring, right? So let's say we are adding servers now. Let's say we have the same 3 servers that we had before, S1, S2 and S3, and we are passing the identifier through the hash function. So there is a key being passed here. This can be the UUID, server IP address, or a host name, something to uniquely identify this physical box into the virtual space, right? So this hash key will return an integer, and this integer represents the position of the server on the hash ring, right? So let's say we got the output like this. For S1, let's say we got the number 0. For S2, let's say we got the number 10. For S3, let's say we got the number 20, right? So we placed our servers onto the hash ring, right? So like I said, we are not actually maintaining this array. So what we will do is we will actually maintain a hash map, which is a sorted map, and we will only maintain 3 records now. One for server 1 object, one for server 2 object, one for server 3 object. Because this is a hash map, we have saved a lot of space and we don't have to do 2 to the power of 32 memory. That's an awful lot of waste of space. When you think of the number of servers we have, we just maybe have the numbers of servers under 10 or 20, right? So for that, we don't need to maintain such a big array. We can simply make use of a hash map and we will just maintain a map. So this part is the index, or you can say this is the position that we got from this hash key, hash function output, and then the right side one is the server 1 object. So using this server 1 object, we can actually physically connect to this database and get whatever data we need, right? So this is the only thing we are going to maintain. This is a hash map, which is a sorted map, and using this we can actually find whatever data points we need, right? So that is how servers are mapped onto the hash ring. Now let's see how objects are used in the hash ring. Let's say we are trying to find some football players like Haaland from Manchester City, Mo Salah from Liverpool, Vinicius Jr., let's say from Real Madrid, right? So we pass these keys to the hash key, and like always it will return some integer, and this integer is telling us about the position of the object on the hash ring, right? Let's say we are passing in Haaland and we got some output, let's say number 2. This is Haaland's position, right? So this position again is not maintained anywhere because we are not actually maintaining a hash ring, but it is a theoretical concept. So how do we use this number 2? We use it like this. So when we get number 2, we want to find the server where this number 2 is, right? So in order to find where this Haaland is located, we need to find the server where this data point is located, right? In order to do that, the consistent hashing algorithm goes like this. Try to find the server which is greater than 2, which is the number 2 here, which we got for this particular key. And then for doing this, we go clockwise on the hash ring. So we go clockwise like this and we find the next nearest server. In this case, we found the server to be S2, and which is having the index 10. So once we have that, we know that number 10 on the hash map will have the server 2 object, and we can go to this server and say get me Haaland, and now in that database we now have Haaland, right? And that's how the consistent hashing algorithm works, right? So once we find the key, we go clockwise on the ring to find the nearest server, right? So let's say there is no server found, right? Let's say we have reached the end of the array and we have not found any server, right? So that's when we jump over again to the beginning of the array and then we find the nearest server. Let's say we don't have S2, S3, so we go all the way to the end of the array and we don't find anything. That's when we jump on to the beginning of the array again and then we start searching clockwise. That is why we need it as a ring and not a simple array, and that's why it is called as a hash ring, right? So just to recap, what did we do here? We sent a key called Haaland to the hash key and we got some integer. We spotted the integer on the hash ring and we went clockwise to find the nearest server, right? If we don't find a server, we jump back to the beginning of the array and then we find the nearest server clockwise from there, right? And the thing to remember is, since we are not maintaining this hash ring anywhere, we only have this hash map maintained. So what we'll do is we'll start looking for keys of 2 and then keep going until we find a match in the hash map, and that's where our server object is, and then we can just make a query and find our data point, right? Now let's see what else is there in consistent hashing. Now let's say we are adding and removing servers. Let's start with how to add a server onto the hash ring. Let's say we are adding the server S4 and let's say we pass it to the hash function and we got the integer, which is the position of the server on the hash ring, and let's say we got the number 5 and our S4 is here, right? So what is this S4 representing? It is representing now all the data points that are in this range, right? So previously the server S2 had all this range, all the data points were coming down to S2 between this range between S1 and S2. Now that S4 is in between, it will take care of all the data points between itself and its predecessor, whatever was there previously in the hash ring, right? So these data points will now need to be mapped to S4 instead of the previously used S2, right? So previously these data points were mapped to S2, now they will be mapped to S4. So only few objects need to be moved, right? So there are some smart techniques to see which data points need to be moved, and only those will be moved. Comparing it with the simple hashing that we saw earlier, all of the data points in the entire database had to be moved, right? Which was very expensive. So compared to that, this is a relatively simple operation and inexpensive in nature, right? The same goes for when a server is removed, right? Let's say our S3 goes down. So what was S3 taking care of? All the data points between S2 and S3, right? All the data points between itself and the predecessor. Now that S3 is gone, all these data points will now need to be moved to the next item in the hash ring, which is S1, right? Again, here also, because it is a ring, when we reach the end of the array, we jump on to the beginning of the ring and then we spot the next server available, right? So all these data points between S2 and S3 will now be mapped to S1. So again, only these few data points need to be moved and the rest of the database can remain intact, right? So again, that is the advantage of using consistent hashing, right? Now there is a little issue with consistent hashing. It is possible that the distribution may be uneven. It's possible that all the data points between S1 and S2 are more and some few data points between S3 and S1, right? So this creates an uneven distribution. So in this case, S1 might be heavily loaded, S2 is completely empty, and S3 is having barely few objects, right? So in order to make this uniform distribution even better, there is a concept called virtual nodes, right? So what do we do? Instead of storing S1 as one entity into the hash ring, we will store multiple entities of S1, right? So because it is just a data point and pointer to the server object, we can maintain multiple such pointers. So instead of doing S1, we now do S1 underscore 0, S1 underscore 1, S1 underscore 2. So instead of one entry per server, we now have, let's say, 3 entries per server. So you can see here, server 1 is here, server 1 is here, server 1 is here, server 2 also has 3 entries, and so on, right? So this creates a better distribution, or let's say even distribution, right? So instead of, let's say, S1 taking care of this whole range, we can now place a virtual node for S2 which can take care of this piece, and S1 again can take care of this range, right? So like that we can do an even distribution using the hash ring concept, right? So this is how consistent hashing works. If you have any doubts, definitely let me know, guys. Thank you so much for watching. Please leave a like if you found this helpful. Please subscribe if you haven't done already, so that you don't miss out on upcoming future videos. Thank you so much for watching. I will see you in the next one. Cheers.